We are in your note packets on the C3 today. I think it's only one. Yep, it's only one-sided page. Here we go. All right. So, before we get started, before you start the warm-up, I just want to remind you that this week, Friday, you'll have a formative. Okay? So, formative this week, Friday, in class, to go along with this week. So, what I would like you to do now is refresher from yesterday. So here's a warm-up problem, 4x plus 7 minus 2x. Tell me how many terms there are. Tell me what all of the coefficients are. Tell me if there's a constant, what it is. And tell me if there are any like terms. So we're doing this one right here. Up at the top of your page, there's a spot for the warm-up there. You want to do that up there. That's great. If you need to flip back to the other side to see what those mean again from yesterday, that'd be a good plan. How many terms? How many terms we got in this one? We got 3 terms. Yep. Okay. Okay. So our first term is 4x. Our second term is positive 7, and our third term is negative 2x. Remember that those subtraction signs go along with the terms, but the positives don't necessarily need to go along with the terms. Okay. Do I have any coefficients? 2 of them. What are they? 4x and 2x would not be coefficients. What would the coefficients be? Say louder, Will. 4 and negative 2. Just the numbers in front make the coefficient. Those would, the 4x and the negative 2x would be the terms. Okay? But the coefficients would just be 4 and negative 2. So I would put those as like terms down here. 4x and negative 2x down there, but just 4 and 2 for the coefficient. Okay. Any constants? What? 7? Positive 7. Okay. All right. Today what we're going to do is we're going to take an expression like that and we're going to condense it. We're going to make it look nice and pretty. We're going to get rid of the repeated stuff in it. We're going to combine like terms is what it's called. CLT, combine like terms. Now today is a very important day in terms of your notes and all that fun stuff. Okay? Because if you don't know how to do it today, the rest of the year, not just the rest of this unit, the rest of the year is going to be more of you're going to be more on the struggle bus for that. Okay? So really focus in on today and knowing what we're doing today. Okay? All right? So let's get the terminology out of the way. Okay? So an expression is simplified. Okay? So kind of like reduced, if you will, like simplified fraction, like reduced fraction. Okay? An expression is simplified when all like terms have been combined. Okay? So when all like terms have been combined. Like terms from yesterday are terms with the same, hold on, that shouldn't be coefficients. That should be variables and exponents. Tap the brakes. We have to change that one. Get rid of that one. Delete that one. We'll move variables over here and exponents here.
Yeah, they do not have to have the same leading number, the big number out in front,
Nope.
but they do have to be like x squared and x squared, or z and z, w and w. Variables and
Coefficient we learned yesterday, that was a number multiplied by a variable, and that coefficient is just that number out in front.
do we have an example like 7x squared and then just write coefficient
Yeah, we just did one.
Oh, yeah, we did that as warm up. Yep. So remember that the coefficient is just the number in front, not the variable. That's what we just talked about. Okay? All right? This is my favorite way to talk about combining like terms. Okay? All right. So let's get the terminology done, and then let's talk about how to do it. Okay? So if we're going to combine like terms, we're going to move all of our like terms next to one another. Okay? So for instance, in the last one, we had, I got to look back and see what it was, and I'll come right back to it. 4x plus 7 minus 2x. So we had 4x plus 7 minus 2x. So what we mean by that is we would move the 4x and the negative 2x right next to one another, and then we would write whatever's left over. So we switch the order around. We put all of our like terms right next to one another. Okay? Then what we do is we add and subtract the coefficients, but we leave the variable the same. Okay, so we're going to add and subtract the coefficients and leave the variables the same. Now, cool, I'll use you. I'm going to give you 3 pencils, right? You agree that those are 3 pencils, okay? Not pens, not markers, not stylus. Those are pencils, okay? I'm going to give you 2 pencils, okay? All right? Now, do you both agree that those are like things? They're all pencils, right? Okay? All right? So if you combine them, how many do we get? Combine them. How many do we have now? We got 5 of them, right? Did those miraculously change into Sharpies? No, they're still pencils, right? Okay? So the only thing that changed is, okay? So if you've got 3 of something, and you've got 2 more of that same thing, okay? When you combine them, they don't miraculously change in your hand. They stay the same. Okay? Same with subtraction. If you've got 5 of something and I take 4 of them away, as long as I'm taking 4 pencils away, the pencils don't change. They don't miraculously change into a book. Okay? Right? They stay pencils. So it always stays the same. Okay? Just the number of them change. Okay? Another way of seeing this for everybody now here is we have 3 pencils and 2 books. Okay? So if I add 4 more pencils, or excuse me, 4 more books and 1 pencil. So now we're going to have, I don't have, let me see. I should make this up. The whole thing. Oh, I should have cloned it. Okay? So if I add 4 more books, how many books am I going to have? I'm going to have 6 books, right? If I add 1 more pencil, how many pencils am I going to have? 4 pencils. Is a book the same as a pencil? No, we can't combine them. So we just have 6 books and 4 pencils. Okay? like terms with the same variable. This is just a refresher here now. And the same exponent. Same exponents and same variables. It's not an or, it's an and. It's a both. Okay? Let's go on to number 1. Okay? Now, stay with me on these. Okay? Don't try and work ahead. Stay with me. Okay? Number 1 says 3x plus 6 minus 5. X, minus 5x. Grab the x part here. Okay? Do I have like terms? 5x and 3x are like terms, right? Do we agree with 5x and 3x, or should be something a little different? What do you think, Will? Negative 5x. I like negative 5x and positive 3x even a little bit more than that. So I'm going to write those two right next to one another. And then I'm going to write down what's left off. Or if I had two things that were like together, I would combine them. Preview of number 2. Okay?
So Linsmeyer, do you ever cross them off when you do that?
When we rewrite it, so like here's the,
Just so we really get to
so
some
make
longer
sure we got them all.
Yeah.
Yeah, that's a good idea
ones.
too.
We're gonna get to some longer ones.
Yeah.
There's gonna be 5 or 6.
Make sure we got all the terms that we have.
After you write one down, yeah. you cross
Yeah,
it.
write one down, cross it out. Okay? Now, if you have 3 pencils and I take 5 pencils away, how many pencils do you have? Negative 2 pencils, right? Okay? Because 3, we add and subtract the coefficients. Okay? So really in my brain, what I'm looking at here in blue is I'm looking at 3 minus 5 times x. Side note, okay? I got done correcting C1's homework yesterday because it was due yesterday. When we're writing expressions now, the x for multiplication can't be used anymore because x is now a variable. Okay? What I mean by that is if we have an expression like 7 times y, I saw a lot of this for that. We can't do that anymore. This doesn't work anymore because x is now a variable. Okay? I accepted that, but I really would like just that. Okay?
And when you have 2 things sandwiched together, that means you multiply.
Yeah. Okay? I saw that on the C1 homework and I didn't accept it. So when you get the C1 homework back here in a little bit and you see that one's wrong and you're like, what did I do wrong? You put it in x. We can't do it anymore because x is now a variable. Okay? So this becomes here negative 2 x's plus 6. And that is our simplified answer. Our simplified expression. Now, in number 2, give me one set of like terms. 2m and 5m. These two are like terms. Give me another set of like terms. 4 and negative 6 are also like terms. If you have 2 pencils and I give you 5 more pencils, how many pencils do you have? You got 7 pencils now. Okay? So this becomes 7M. If you have 4 books and I take away 6 books, how many books do you have? Negative 2 books. Okay? So then this would become minus 2.
That is simplified.
And that is
2 does not have an M, so we cannot combine them. They're not like terms.
questions, comments, concerns, clarifications. Okay. Let's try number 3 now. Now this one's a little bit longer, type 1. Okay. So in number 3, give me a set of like terms. 3x squared and 2x squared. Okay. I like it. Give me another set of like terms. Negative x and negative 5x. Oops. You can just write minus 5x there.
Alright.
Okay. So now I should cross out what's left. Just 10. Yeah.
And always take the sign that's ahead of the number. Yep. It's minus, you put minus, but this one just says plus 10, so we're going to put a plus 10 at the end. So now we rewrote everything. Good.
Okay. Blue is, what do you want blue to be? We've used pencils and books. Give me something else. No, not a color. Give me an object. Calculators. How many calculators do we have? You got 3 calculators, and I give you 2 more calculators. We've got 5 calculators. Good catch there, Mr. H. I mean, this is good. Okay. All right. If you've got -1 sharks, and I take 5 sharks away, how many sharks do we have? Nope. You got -1, and I take 5 away. -6 sharks. And then the plus 10 just comes along for the rest.
How is that simplified?
Yeah, because the x's, there's 2 x's though, right? But are they the same? Why not? Because what? Because one of them's squared and one of them's not? Yep, so they have different exponents. Okay? I'm going to give you 5 minutes, which should be more than enough time for you to do the next 3. Okay? Do those bottom 3, 4, 5, and 6. All right, so in number 4, what are my like terms? Four n and 3n. So I can start by writing those together. 4n plus 3n. Any other like terms? No, there's no other like terms. So I can just write then plus 5 plus 6m. And so my answer here would be 7n. This is the most popular answer that I saw walking around the room. That works. I love it. Okay? But Will and I were having a conversation in the back, and I said, what if I wrote it like this? Is that still the same thing? Yep, that's still the same thing. Okay? What if, because I like being in alphabetical order, what if I wrote it like that? Still the same thing, as long as all of my coefficients are the same. Okay? As long as my coefficients are the same. Now, here in number 3, I forgot to tell you, we like to put the biggest exponent first. This is called standard form. Okay? We like to put the biggest exponent first, and then the next biggest, and then the next biggest, and the next biggest, and then just our numbers at the very end. Okay? Now, when you've got multiple letters in there, then it gets kind of on your own. Right? But that's up to me and Mrs. Hill to figure out, you know what I mean, if your order works or not. Okay? Love it.
Mr. Lincoln, do you think we have any brave volunteers that want to come up and try one?
Come up and try one. I saw a lot of people with right answers. Anybody want to come up and show us what they did?
Maybe not today.
Maybe tomorrow. Maybe tomorrow. Okay? Like terms in number 5. What are my like terms in number 5? 4x. Do I like 2x?
No. What's in front of the 2x? Negative.
Negative 2x.
Take the sign. That's okay.
Keep the sign with it. And negative x. Okay? Those are all my x-like terms. What are my other 2 like terms? 3y and 7y. If I got 4 candy bars,
There we go. Thank you.
and I take 2, and Mr. H takes 2 away.
4 Snickers. That's my favorite.
Okay, so if we got, how many Snickers bars do we have left? 2. Then Mr. Brown takes 1 away. How many Snickers bars do we have left? 1. We got 1 Snickers bar. It didn't miraculously become a whatchamacallit. That was my favorite one growing up as a kid, a whatchamacallit. Okay? Alright? It stayed a Snickers bar. Okay? 3 Butterfingers plus 7 more Butterfingers. How many Butterfingers? You can just say the word. So you're going to hold your hands up as opposed to just saying 10. Right?
So 1 Snickers and 10. What happens if you put a 1 in front of the X?
Oh, yeah, like this. Is that okay?
What if I said I have a Snickers bar, or I said I have 1 Snickers bar? It's the same thing, right? Snickers bar or 1 Snickers bar. You only have 1 Snickers bar either way. So it doesn't matter. If
So
you
it
put
doesn't
one
matter if
X.
you put that 1 in there. Yep.
Okay.
Yep. If you do, that's fine. If you don't, because there is only 1, that's fine. Now, what if I didn't put the 1 here on the 10? That's different then, right? Okay. That's a whole different story then. Okay. All right. Number 6. Like terms with x. Do we have any? We got a 3x. We got a 12x. And we've got an 11x. Okay. Like terms with negative 3y. What kind of y? Negative 2y. And what? Negative 1. Yep. Okay.
And my favorite thing in math is to cross things off. So
Yep.
I'd be crossing off.
Yep.
After
Or-
I write them.
If you don't cross
Or do
off
the
and you
arrows.
put the arrows, that's fine too. Okay?
Some way
But
to know that you used them all.
that you got them all, and that you hit them, you got all of them there. Okay? All right? 3. What are we going to go with this time? What's going to be our item?
For the X, what are we going to say?
What are we going to say? What? No, what's our item?
What's X going to represent?
So what X? So like we've been saying pencils, and then we went to candy bars, and we did sharks, and we did chairs. Chairs. Okay. So if you got 3 chairs, you're having a big party. You got 3 chairs, and you need 12 more. So somebody brings you over 12 chairs. How many chairs you got? 15 chairs. And then you say, still don't have enough chairs. Somebody else brings you 11 more chairs. How many chairs you got? 26 chairs. Huh?
We're talking about chairs. What else is on chairs?
Might as well go with tables, right? Okay? So if you got negative 3 tables, which I don't know how you're going to have negative 3 tables, but you got negative 3 tables because you borrowed them out to somebody. Okay? And then somebody else says, I need 2 more. So now how many tables you got? -5, right? And then somebody else said, then your mom says, I need a table. You got -6 tables. Yep. Okay.
6 chairs, 6 tables. That'd be a good problem to put on the end of their assessment. Now, how many chairs go with each table?
Go with each table. Yeah. Arrange the chairs in such a way
That's
that
the picture and color it. Nice, that'd be a fun
such that
test.
yeah.
That'd be a fun test.